In this video, I'll be covering type conversions using the from and into traits. First, as you know, Rust utilizes a robust type system. This leads to more reliable and easier to maintain code, but it also makes it cumbersome when you're working with similar types and wrapper types, usually in the form of extra code when you're working with these types. However, Rust provides a trait that can be used to easily convert between different types. These traits are called from and into. The from trait starts with a type that you want and will convert another type to it. The into trait starts with a type that you don't want and converts it into the type that you do want. Let's take a look at a few more details before jumping into an example. The from trait is an associated method on a type. This means it is a free function that can be accessed using the type name as shown. When implementing the from trait, you will get into implemented for free, so you'll almost always just implement the from trait. The into trait uses a self method on the type to perform the conversion, so you'll use it as shown here. Let's take a look at an example to see how to use these traits. In this first line here, we want to create an owned string. To do so, we'll use the string type, we'll use the path access operator, and then we'll use the from function that's defined on the from trait. We then pass in a string slice to the from function, and it will convert from this string slice to an owned string. On the second line, we're utilizing the into trait. When you're using into, we have to specify a type. So we're using a type annotation right here to specify that we want an owned string. We then take a string slice, call .into on it, and it will convert from this string slice here into an owned string. The into trait is very useful when you're working with functions, like down here. This function has a return type of an owned string, but we are working with a slice as a function parameter. All we need to do to convert this string slice into an owned string is just call the .into function on the string slice, and then we'll get back an owned string because it's going to turn the slice into an owned string. Since we're using the .into function here, we have to have an implementation of the into trait for the string slice to an owned string. This is implemented automatically by Rust, but if an implementation did not exist, then you would get a compiler error when you try to run .into. So if you want to convert between types using from and into and you get a compiler error, then all you'll need to do is implement the from or into traits, which we'll be doing next. So here is an implementation of the from trait. Here we have an enum and it's named status. So this will be like the status code of some kind of device. We have a broken status with a code, and then we have a working status. For our implementation of the from trait, we're going to use the impl keyword from, so we're implementing the from trait for the status type. You'll notice we have generics here, so we're going to implement from the type that we're converting from, and this will be the type that we're converting into. So you can just think of this as we're converting from a U8 into a status. There's only one function we need to implement for the from trait, and that's the from function. So the from will have a single function parameter, and it has to be the type that you specified here in the generics. So we have a code, which is a U8. It's always going to return a self, and as we know, the self refers to whatever we're implementing for. In our function body, all we need to do is return a new status as a self, so we can match on the provided code. And if it's 0, we're going to assume that something's working. And any other code, we're going to return a broken status with the code. Now that we have a sample implementation of the from trait, let's take a look at how to utilize it. Here we have a function, and it just returns a U8. Within the function, we're returning a 5. So this legacy interface is going to return a status code of 5 as a U8. So we have two options here for turning the 5 into an enumeration. So on this first one, we'll use the into trait. So with into, you have to specify the type that you want. So we're using type annotations here. We call our legacy interface function, and then we call the into function. When we call that function, it's going to turn this U8 into a status. Since we implemented from on the previous slide, and whenever you implement from, you get into for free, we're able to use this first line to obtain an status enumeration from a U8. Alternatively, we can use the from trait like we do on the second line. Here we want a status, and we want to get one from a legacy interface return value. So we call the legacy interface, and this will return a 5, and we'll take that, and we'll attempt to get a status from that, and then that'll be saved as the status variable. Again, since it's already implemented, it will compile fine, and the conversion will be performed successfully. Here are some pro tips when working with the from and into traits. These traits cannot fail. There is another trait that allows failure, but from and into must always be successful. You will almost always want to implement from for error types. That way they can be easily converted between different errors. The this error trait, utilized in the previous lessons, implements the from trait when using the from annotation. You should prefer to implement from instead of into. This is because implementing from gets you an into implementation for free. When utilizing these traits, use .into when it's obvious what the resulting type will be from reading the code. You should use type from when it is important to emphasize that a type conversion is happening and to show what the resulting type will be. Using into many times consecutively will be difficult to read, but using from will be easy because the type is shown as part of the conversion. One last thing before we finish up. You can also utilize the question mark operator with the from and into traits. So here we have a job structure and a job error enumeration. The execute job function will try to run a job, and it'll return an error code if the job fails. We want to turn that error code here into a job error enumeration. To do so, we implement the from trait on a U8 for a job error. So we're going to convert from a U8 into a job error. In our from function, we take a code, which is a U8. We're matching on the code, and if it's 1, we'll have an expired job. If it's 2, of a missing job. Any other code will have an other job error code. In order to get a job error enumeration from a U8, we can use the question mark operator. The question mark operator, when used, will attempt to convert whatever type is within into whatever type is being returned as an error. Since we are using the question mark operator, the function must return a result. If you attempt to use the question mark operator to return a job error, and if we didn't have this implementation, then you would get a compiler error saying that we have mismatched types. However, since we did implement the from trait for the job error, we can do this no problem, and we'll get a job error back, even though we just have a 2 right here in the error. To recap, the from and into traits allow conversion between different types, and it's important to note that the conversion cannot fail. You'll prefer implementing from over into, and that's because into will automatically get implemented when you implement from. The question mark operator will automatically use a from implementation to convert errors if it is available.